Hello, and thank you for joining our webinar on advanced analytics and the Power Platform. Today's presenters are from the data team here at SPR. We're a digital technology consultancy in the Chicago and Milwaukee regions that helps clients use modern technology to transform and innovate businesses. Today you'll be hearing from SPR's Director of Data Science, Ray Johnson, and our Senior Principal Architect, Will Robinson. Will and Ray will open the floor to questions, but at any time, feel free to email comments or questions to our data team at the address you see here on your screen, info@spr.com. And now I'll turn it over to Ray and Will.
All right, thanks everyone. My name is Will Robinson. I'm a Client Solutions Principal here at SPR, and I'll be talking a little bit today about Power Apps and Microsoft Flow. Ray and I did this presentation at a recent Power conference, and we'd love to kind of share this with you guys today. Feel free to ask questions. How we're going to do this is we're going to start off by really giving the presentation the way we did it in the conference, so more from an end user perspective, and then we'll use the last half hour of the lunch and learn to dive into some of the technical details behind the scenes. And with that, I'll turn it over to Ray.
Hello, everybody. This is Ray Johnson, and I'm going to be working here with Will, going through the presentation, primarily functioning and responsible for the areas related to advanced analytics and machine learning. So we're going to be looking at tapping into advanced analytics using the Power Platform. The specific use case we're dealing with is customer retention and engagement. And we're going to do this through the eyes of one of our friends, which is named Sydney. So, who's Sydney? So he's an account manager at an e-commerce company, and he's trying to make sure that all the customers that he has are happy, and to keep them from, leaving and going to a competitor. The issue is that Sydney has hundreds and hundreds of accounts that need to be managed to make sure that everyone is happy, and there's just not enough time in the day to get all of this work done. So he gets the idea, hey, maybe I can leverage machine learning to start to be able to tell me who are the people that are going to leave or potentially going to leave and migrate to another competitor. So a machine learning model has been put together that's going to best predict the likelihood of that customer going to churn and then move over to a competitor. We'll delve into this in a little bit more detail. Sydney also says, hey, I've now got a nice, cool dashboard that I'm looking at that will let me see which customers I should prioritize. And the dashboard says, hey, here are the ones that are at high risk of leaving. So let's take a look at Sydney's current environment and then how he has progressed from this more descriptive environment to a more predictive environment. So right now, this is Sydney's current world. This is in Power BI. It's a Power BI report. This is just based on existing data. This is the world as they know it. And they know what customers have left. So you can actually see here, you can see it says count of ID by the area code. So it shows the ones that have churned. One is churned, 0 means they've retained that person. And so you can see they can look at it by zip code, delve into that. They can look at it based on a particular state. We can actually see, here's Arkansas, and it shows you the number that have churned out, number retained, and that's given to you as an percentage. We can look at the client details, and the client details will show us by state all the accounts, using the phone number as the account number, what type of charges they've incurred, and how that charge has been dispersed and how it's relatively dispersed throughout all the different classes of charges. Also, we have information about customer service and say, hey, we can see all the accounts, we can see the customer service calls, we can see customer service calls for churned individuals, and we can see the total charges. However, having all of this just really isn't enough. I mean, this is telling you what has happened. So from that perspective, Sydney can go in there and say, you know what? I can tell you last month we had this many people leave. However, someone is now asking the question, well, what about next month? And what about coming up? He goes, oh, we have to get to that. So they said, well, let's take a look at ML and see how that can help us. In that case, we now have an Azure ML machine learning model. And this model is pulling together data from multiple sources. This is a CSV file that contains call data. And we can actually look at this call data and visualize it. And it shows us each column, each attribute, and what the distribution is within that attribute. We can see. And then we have some other data that's actually coming from an Azure SQL database. And then we can see that has things related to the account list, link, whether or not they've churned, what type of plans they have, all of that. And again, you can see the distribution of the data. That data is then joined together, where some metadata is changed related to the names of the columns and their types. And then they decide, okay, let's go ahead and figure out how we're going to do it. They say, well, since this is going to be something, a classification problem, we want to decide, are they going to churn or not? So it's class. So it's two classes. And in this case, they say, well, we're going to use a decision tree for one algorithm to check. And we're going to use a decision jungle for another. So they then go to take the data that's been brought in, and they're going to split it out. And they're going to do an 80% split, so that 80% of the data goes to training, and the 20% goes to test. And then they pull in their train model for decision tree and train model for decision jungle. They then score the models. And when we go into the score data set, we can visualize it. What we see are all the individual pieces and attributes that make up that data. And at the very end of it, we get an interesting field. One is called scored labels. And what the scored labels is basically a flat binary yes or no, where 0 indicates no churn, 1 indicates churn. And then we also have the scored probabilities. So you can see here are the probabilities of them churning, and here's whether or not they churned in total. So you can see here's a 1 related to 0.77%, 77%, almost 100% here, and you can see that. So that's one. And then we have the same thing over here where we see another scored model for the decision jungle. The next question is, what do we do with the model? Which one's actually giving us the best? So we have a evaluate model node, and that model evaluates the nodes and pulls out the information from them. And one of the pieces of information is model accuracy. So in this case, we have another node that says select columns. And so we're going to select model accuracy. Now, each model type or algorithm type has their own attributes. So depending upon if you picked up decision tree, clustering, neural network, you will get different values in here for the evaluate model. So in this case, we pull those out. And now I have a little R script down here. And what this little R script is going to do is it's going to read the evaluate model node output and put names to it. So it knows the first one was decision tree, and I put in the second one is decision jungle. And it's going to combine them together so that we can see the information about the models and how well they did. Once that is done, we see the visualized output. And we see, oh, the decision tree gave us 94% accuracy. Decision jungle gave us 85% accuracy. So in that case, we decide we're going to take the output from the scored model that gave us the most accuracy, and we have the ability to take that scored model and send it to the Azure SQL database, and that's where we're doing it. So that goes to the Azure SQL database. Now, Sydney now has a new tool in his pocket where now he can actually look at the predictive capabilities and see how likely is someone going to leave. So let's take a look at our customer summary, but now we're going to predict it. And you'll notice these all say predicted. And so it's pulling churn predicted, total retained predicted, the percent churned. And if you notice now, there's another extra column. You'll see scored probabilities are now showing up. And you also see that it's by state. So if I wanted to delve into a state, like let's say I delve into Arkansas, I can see, one account here is gonna churn, and these are the ones that are gonna stay. So I now know to focus on this person. Now, how these people are selected, there's another model that you would more than likely use, which is called a lifetime value model. What that lifetime value model would say, here are my customers, and this is what the value they're going to contribute to my organization over time in total. And you really want to focus this possibly, maybe you do it on your top 10% of your customers. But in this case, what we're doing is we're showing you that you can actually then get the details of who is going to leave and focus and target in on them. So this is all well and good. But the problem now is the next piece is, well, I really want to get notified. I mean, it's okay if I come in here, but I want to be notified on how these probabilities are affecting my customers and whether or not I need to address them, and I wanted to be more proactive. So let's take a look then at the next piece where Sydney decides, I'm going to go ahead and create myself a dashboard. So he creates a dashboard. And he puts in the stuff here. And one thing he takes advantage of is that for this one, it shows a target of 5%. And of course, this is above 16%, so they've got some issues here. He says, whenever that threshold exceeds a certain value, I want to get a notification. So he will go to Power BI, and he will go to Manage Alerts, and has an alert for percent churn. And it says, whenever it's above 5%, send me a notification. The issue here still is that, well, it's sending this to me when it's predicting in aggregate what the entire 5% is, not necessarily the individuals. So he looks down further and he sees, hey, look at this Microsoft Flow thing. I can trigger additional actions using Microsoft Flow. I wonder what's that about? So Sydney decides now to contact support group and say, hey, can you help me with Microsoft Flow and Power Platform to help me get a more proactive alerts related to this data? And at that point, Will steps up to the plate and says, I can meet your needs. So now Will is going to show you then how the Power Platform can be used to facilitate this proactive type of alerting and messaging and interaction. Will?
All right, so what we have so far is that Ray has talked about how we've trained a couple machine learning algorithms and we picked one that is giving us the best results. And he's also shown us how we can use Power BI to effectively manage our account list. Now, this scenario applies to really any customer service type of situation. But I want to show you a different way of managing your accounts. If I'm an account manager, I may not be able to go into Power BI, or I may be away from my laptop, but I have my phone. On your phone, you can get access to Power Apps. You can also get access to Power Apps through a browser. What you see on the screen is an example of a Power App that we've created for this scenario. And the scenario is that the account manager wants to get up in the morning and figure out where am I going to spend my day? How am I going to spend my time? And who are the most at-risk customers that I want to deal with? And what I've done here is I've created a Power App that brings in data, brings in my accounts, so it filters on my own accounts, and it shows them to me in a list form in a kind of a small space. What you see on the screen is I am pulling data from the Azure SQL database, that is the machine learning data, and I decided to display 3 key important pieces of information that displays for each one of my accounts. And I'm sorting by the highest churn prediction. At the top, you see 98.57%. That's a very high chance this person is going to leave as a customer in the next couple of years. I need to call them today, or send them an email, or send them a gift card. You know, whatever we do to retain our customers, depending on the situation. And what Power Apps does is it's very easy. I'll show later. You can easily pull in data into this gallery, what it's called, and get the information. You can also click on this, and it gives you a details pane that really pulls in even more data from the SQL database. I just left it as the default look and feel, but you could change this, and it just brings in more information about that client before you call them. A couple other things, you know, I've got some conditional formatting. For example, you can also search. I just type in 1293 at the end of an account number, and it filters it out for me. That's all built into the default Canvas Power App that you create out of the box when you start off, which is one of the reasons why this is you know, being shown as very user-friendly for these non-developers, power users inside these enterprises. A couple other things to note. I dropped in this little number that actually tells you how many are in the search results, so I kind of know. I also put a little number here, 55%. So what does that mean? This represents my personal threshold that's important to me as an account manager. And so what I'm saying is anything above 55%, show me those results. That's pretty straightforward. One thing to understand is that Power Apps doesn't have its own data store. You have to always supply the data location. And one natural piece to a Power App is there's personal settings. If I want to personalize this app to only show me information that's important to me, I need to be able to select personal settings to do that. And I created a new screen for my personal settings. But where would I store that? In my example, and you could have stored that in SQL like I did the other data, but I decided to store it in a SharePoint list. Very easy to create. I created a SharePoint list called personal settings. I have the account. I have a notify yes, no, so notify me on when things change, and then a threshold that's my personal threshold, and mine's at 55%. So in my Power App, I am pulling in data from two locations, and one is a SQL table and one is a SharePoint list. If I go to my personal settings, what I'm doing is I'm at this top section, I'm pulling in that SharePoint list. So my notifications are on and I'm 0.55, just like in the SharePoint list. That's pretty simple. Now on the bottom, I've added my own fields to bring in just to confirm that my app is working. I'd probably remove these for production, but the entire list is also sitting down here below so I can see. You know, if I hit notifications off, down here it shows false, which just proves to me that when I go back to the list, it should show false. See if we can refresh. So it's refreshed as false or no. And so I'll go ahead and set that back. Now, when you look at this, I have 14 results and 55%. That's a really low threshold, actually. So I'm going to make it 85%. I click update. I send the update to the SharePoint list, which happens down here if you look. And then I pull back. And then, so when I go back to that screen, it pulls the data automatically for me using the filters. And now I'm down to 6. So now I can go ahead and pick these 6 that I want to look at. And 85% is the new threshold that I set. So this is how my account manager can manage his or her day. Now, let's say, for example, so we got two situations, Power BI and we have Power Apps. But now say that as an account manager, I may only go into my app once a day, twice a day. But if somebody goes from low probability to very high probability due to the machine learning kind of predicting it, I want to know immediately. I don't want to wait to go into the Power App. So you can use Microsoft Flow to listen for changes and actually trigger a notification. So now I'm going to show you, this is a Microsoft Flow, a very simple one. This is kind of the main dashboard that you see, and it shows the connections. I'm using the Microsoft Flow to connect to SharePoint. I'm connecting to SQL, It gives me a history. I turn it on or off, and I'm going to go ahead and edit this. Now, the Microsoft Flow is, in this example, is really simple. The first part is I'm essentially going to listen for a change in the SQL table. And as long as the records have a unique identifier and a kind of a time date stamp, or basically a version number, Microsoft Flow can listen for record level changes and then do something about it. So for this one, I'm just going to pull in the entire table and look for any changes that happen in that table. And when I do that, when there's a change, I want the flow to trigger. You can also have Microsoft Flow start by clicking a button. You can have it start on a schedule, like 9 in the morning after the machine learning algorithm refreshes. In this case, I'm actually listening on the table for something. Now let's move on to what happens next. Now I want to go into SharePoint, and I want to grab my personal threshold setting, right, that I've set myself. So when there's a change in the table, I only want to be notified when something important happens, when a customer of mine goes from low probability, which means happy usually, and then high probability, which means very unhappy. Okay, so filter that out. And then if that happens, I go to the last part. And what I do is I compare the scored probabilities value in the SQL table, which what the machine learning algorithm has come up with, to the threshold I have set in the SharePoint list. If it's greater than that, that's a problem. Send me an email immediately. So I have a send me an email notification. And what you notice is that I can embed in the email data from the SQL table in red and data from the SharePoint list in blue. You very customize this and make it very dynamic. And I'm kind of saying, customers at high risk, do something about it, so that the account manager can actually take action right away. So let's see this happen. I'm going to click on test. So now it's listening for change. I'm going to go into to the SQL table. This is the machine learning table. I have this here. This is set to 0.005, which is very low. I'm going to change it to 0.93. Click enter, which updates the table in the SQL table. And I go back, and it's thinking right now. And it says it ran successfully up here, and it checked green on all of these, and it ran. So I go into my email. It's 12:23, and I get the email that says, customers at high risk of loss. I embed the account number. I talk about the predictor score and what my threshold is. And now I can take action as an account manager using Flow. All right. So now what we've done is we've kind of shown 3 different examples of how to inform an account manager using machine learning to predict when a customer may or may not leave as your customer. This really concludes how we would do our presentation. The next step is for us to kind of dive into some of the details on how this works.
Okay, so from a machine learning standpoint, what we're seeing here is the Azure ML Canvas. And in here, you can specify any type of data sources you want. You can see down the side here all the options that are available to you. And then have also basic querying capabilities where I can join data, I can edit metadata. The key thing are these algorithms that are picked, so that if you go into Power BI, go into Azure ML and look at the machine learning list and look at the models that are available, you can see there's a variety of these models that are here that we can actually leverage to pull data in. Okay. In this case, we decided to use the decision trees in order to do this. Now, one thing is this is different from other tools in that when I have a particular model that I select, there, I now have all of the parameters related to that model right there for me. So I can set if it's a single parameter, do I want how many leaves per tree, the number of leaf nodes, learning rate, number of trees constructed. I can specify a lot of these. I can set a default seed so that every time this runs, it will go through the exact same process. Otherwise, if I don't put this value in and have it set randomly itself, I can get different results. So this allows me to maintain those results. There's also the ability to actually run another piece in here, which is called the parameter sweep. It'll actually automatically try to tune these in order to get you the best results based on that particular algorithm that you're running. Now, typically you would not use just one, you use multiple algorithms. And that's why you'll see here, it says 2-class boosted decision tree. And over here, it says decision jungle. They're both being pulled in. And then the split data is going to this trained model node with an untrained model that gets here, and a trained model node here, and this is an untrained model. And the data that's being split, the first part is the 80% is going into this model, and it's going to here. So you can actually have this data go to multiple models at the same time. The training data, the test data is then being sent from this node down into this score model node. And then the decision tree is being hooked up to that. So what this effectively is doing is it's training the boosted decision tree, then taking its output and then pushing it down into this area so it can score the model. And you'll see it says score model here. One is for decision jungle and one is for the decision tree. The last piece of this is then this evaluate model. And it'll evaluate 2 models at the same time. Now, if you have more than 2 models, what that basically means is I have to go through score model, and then go have another 2, which would be, let's say, another scoring the model, and then have another evaluate. And basically, I'm funneling down all the models till I get to the point where I only have one node that says evaluate model. I can then select any of the columns from that output versus where it could be the accuracy, it could be R squared if there's error there. I can see all of these types of things. I can get values if it's clustering based on the nodes, as far as what the cluster and a member belongs to. And the final piece here, this R script, is actually pulling that all together and putting some intelligence around it so that I can distinguish which elements are there. Now, the output from all your scored models, I went ahead and manually take the scored model, and one of the options is I have the scored data set. I can save this data set. When I save it, it will then show up over here as saved data sets. And you can go in here and you can see it says customer churn predicted, and there it is. From there, I can take that churned data set or that saved data set and then export it to any place I want. In this case, I'm exporting it to an Azure SQL database. In a production environment, what you would typically then do is once you have all this fixed and you decide what model you want, you would delete the evaluate model out, and then you would plug in the destination where you want this model exported to, and you would take the scored output and send it directly to the Azure SQL database. You also have the ability then to set this up as a web service. So if you go to set up web service, which is along the bottom here, what it will do is it will actually create endpoints for you where you can call the web service, whether it be a flow or any other way you'd want to call that web service, pass data into the web service by doing a call, and then you can do a get, send it in and do a get, and you can get the response back and use that response to populate another application with it. Now, this is in a free account. As you move up the chain, you also have the ability to scale this. So you can go in here and scale it up to any number of nodes, any number of servers to handle more and more data. But this is how that model generates that data. And it will take it all, write it out to that Azure SQL DB, where Power BI is now tied into the Azure SQL DB over here under this customer predicted. And that's where you get the scored probabilities, because those scored probabilities came from the scored probabilities off of this model. And that's that column over here. There we go. And that's the column back over here. So this hides a lot of complexity. If I wanted to, I could have done all of this even with an R and just put a whole bunch of R scripts in it. But this is showing that you can actually put this together very straightforward in a quick amount of time, small amount of time, and produce a model that will actually do these types of predictions for you. So I'm going to leave it open now. Does anyone have any questions about how this model is running or what's happening inside of this Azure ML environment?
Hi, this is Tuan. I have a question.
Yes.
Yeah, so can you tell me the process of how you choose the decision, about how you pick the decision, like decision jungle versus the decision tree?
Okay.
Can you tell us the process of why you're picking those two out of many different decisions?
Okay. Well, one is looking at the type of problem it is. It was a classification problem. So that immediately pairs down some of the things you want. I also know that it's a two-class problem. It's either basically class 1 is yes, class 2 is no. So based on that, using that as a starting point, okay, I could then go in and then look through all of the available models and features that are available under machine learning, and then I can actually pick what's available for it. So here's like classification. And I've also found that for these types of models and these types of classification problems, decision trees work fairly well, and they're really easy to understand. So if I were to go and visualize this, it would be very clear as to why this particular model is doing what it's doing. Now, the decision tree, in this case, what it's doing multiple trees. So it's actually using 100 trees and randomly taking dozens of variables to calculate what the best option is within that tree. And then based on that, it's then returning results. The decision jungle is a little different because what this is, okay, this is a little different. This is an extension of a decision tree. And what it does is, instead of having only one path to a node, you have multiple paths. So I could have 5 or 6 different ways to get to a node. And what that does is it reduces the number of nodes that you need and the amount of memory. There's a really good paper on these. Basically, it's using what's called a graph underneath to tell it how many paths are going to a node, and then it picks the best path based on that node. And so you can actually set the number of nodes you want, how wide you want the tree, the depth of it, and so on. So a lot of the selection goes into what is the type of problem you're doing. Are you doing a classification? Are you doing a regression type of problem? Are you doing a, let's see, maybe you're trying to do something with dimensionality reduction, things of that nature. And that can also be a problem in here where you can actually use machine learning to determine the number of attributes that you need. Does that answer your question?
Yeah, thank you. Yeah, I was wondering that maybe you would consider regression, but you answered my question.
Well, the reason I didn't consider regression is, one, I was trying to not really predict a real or a real value. I could have tried to use a regression tree, but what would happen if I did use a regression tree, I would look at it and say, at each one of those nodes, I could have actually a formula within that regression tree. In this case, what I'm doing here is I know that I'm trying to just do a specific classification. And it was basically a 0 or 1. I'm not looking at trying to predict classes of values where I would have something like, well, if it's logistic regression, I would have red, green, blue, something of that nature. I'm actually just predicting a simple class of 0 or 1. And that made using a decision tree much easier to use versus doing something like a regression tree. Does that make sense?
Yeah, makes sense. Thank you.
Okay. Any other questions? Okay. So if that's the case, Will, can you then get into the guts of what's happening under flow?
Yeah, sounds good, Ray. Thanks a lot. Let me share my screen. I want to start off by just starting with the basics. Power Apps and Flow, they were designed for non-developers. Some people are calling it citizen developers, power users, but people who understand their own business very well and they want to quickly create solutions. So Power Apps is really that solution for real-time, near real-time updating of data, and Flow is for near real-time to batch of data. And so let me start by just showing you how easy it is to create a Power App. You find Power Apps in your Office login, and some of you may have to go in to explore all your apps, but as you start to use the apps in Office, they start to bubble up to the top. So if I go into Power Apps, what you can do is if you know your data, where it's at, and you want to start with that, it's very easy to get something going. So I'm going to start with data and create a Canvas app. And what you're going to see here is I get it. So they give me some common data sources, and I don't like any of those. So I'm going to go, and I can look at my existing connections that I've used in my other Power Apps. If I click New Connection, you can see, look, there's Amazon Redshift. There's all kinds of external connectors you can connect to. Oracle, Teradata. I'm going to go ahead and connect to that same database that we just used. So then I have it set. These are tables and views. Somewhat recently, they added a view capability. I used a view in our demo because I wanted to join the machine learning data with the service rep account name assigned to each one of those records. And hit connect. And it's building the app for me. Now the Canvas app will give me a couple screens out of the box. And so it just brought in whatever it wanted to in terms of the top 3 records or columns. They're called galleries. So the top one is the gallery you edit, and the other ones just follow suit. They just copy the formatting and the text that you have in here. So I have all these brought in. It gives me a search box. It gives me a detail screen, what you already saw, out of the box. So within 5 minutes, you actually can have yourself a Power App. A couple things. If I wanted to actually insert something similar to what I had before, for example, a number count. Oops. Do a label and put it down here. It's just a text label. And then in the advanced properties, what I would do is I could then change the value of what this is to a number. And I would do similar to what I did here, going into the old one. What I did was, in the text box, I just typed a expression, count rows, and I browse the gallery, which is all these rows, and actually count them up. And so I could easily place that in the same one if I wanted to. So for here, I could do count rows, and then just do my gallery is also called browse gallery 1 dot all items, and it does an immediate check for me. Click out. Which one I want to go? And it has 100. So I brought in 100 rows from that SQL table by default. So then also you have on the detail screen, it brought back 8 different columns in the SQL table. Now, I could add to that if I wanted to. If I go to the detail form, which actually pulls in the data, there's a data source field and it's edit fields. And I can, right now, if these line up, if you look next to it, it's the fields here. They're called data cards in Power Apps. And I can go and grab the service rep name, which is, and this one it's Ray Johnson for this example. What's nice about Power Apps is it actually pulls back real data and gives you a real preview, which I think is very helpful. And so now I've added that. So let's go back to my app that I created and kind of go back to the gallery. So in the gallery, to pull back all the list of the, I have 6 right now, I'm basically creating a filter on the data connection. And what I chose was I'm bringing in these fields to show. So area code, initial plan, phone, the service rep, contact. And then I'm actually doing a comparison that the score probabilities value is greater than or equal to my current threshold, which is a variable that a Power Apps variable I set, which is equivalent to that threshold that each user has of their own. So I wanted to basically compare the two, but I also didn't want to see anything at 1, because if something is a probability of 1, I'm assuming they're kind of they're a customer that's going to be gone anytime now. So I wanted to filter out that noise as well. And I also had to match on myself, which in Power Apps it's user.email, the account name. So there's that. A couple other items to kind of show you. If I go down to, I'll also show you this. So this is a field I just dropped in. And what it is it's showing the actual value of the threshold again, 85%. And down here in the text of that, you basically use an expression. So you're not really writing code, but it's what's in that text. And I'm actually going and getting the threshold underscore data card 1. That's an object or an item value. And that actually sits in the other user settings page, which is this number right here. This is the card itself. Oops. Sometimes it's easier just to go down and actually select the card on the left navigation. So you have the left card, and it's basically picking up that 0.85 value and showing it on the other screen. Something else to show you is on the update button. It's separate from the data in the SharePoint list. But what I'm doing is I'm saying when you click the button, patch is the expression that you use in the Power Apps to actually write data somewhere to another data source. And I'm going to the personal settings underscore 1 list in SharePoint, that connection. And what I'm doing is I'm looking for a match on my username. So I'm finding the row in the SharePoint list that matches me, and then I'm writing the current threshold value of 0.85. And that's really how you write data back to a list, a database, or a table, sorry, and other content sources. I'd like to thank everybody for joining the Lunch and Learn today. Hopefully you guys learned something about machine learning and Power Apps and Microsoft Flow and Power BI. And if you have any questions, feel free to reach out to Ray or I. I appreciate it.